Hello and welcome everyone to my channel Code with Ease. Today we are back with another problem on binary search. It is called find the peak element. So peak element related questions we have started doing in the last few weeks. Peak element concept is a very significant concept in terms of binary search related questions, and we'll cover that what is peak element and what we're supposed to do that. If you guys have not checked out the series that we are doing as part of the binary search, I would highly recommend to check that out in the description, and I'm also going to link it up above. Do start following the series from the first video in which we have done a complete overview, dry run of the binary search, and then one by one we are doing the questions related to binary search. So do check those out. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. Now back to this question. First of all, what is a peak element? Um, this peak element concept has come from a special type of array which is called a mountain array. From there only we have started to learn about peak element or peak index. In simple words, as it says that it is an element that is strictly greater than its neighbors. So whether it is the element to the right hand side or it is the element to the left hand side, the peak element has to be that particular element which is going to be greater than the element on the left hand side also, and it is also going to be greater than the element to its right hand side also. So in this question, what we have to do is we are given a zero indexed integer array. We have to find a peak element and return the index. If the array contains multiple peaks, we have to return the index to any of the peaks. And we have to write this algorithm, which is anyway going to run in order of log n, which means this is a clear indication that we have to use binary search to solve this. So if we see this example 1, 2, 3, 1, here 3 is considered as a peak element. Why? Because 3 is greater than 2 and 3 is also greater than 1. So 3 is the peak element, hence the output is 2 because the index of the peak element is 2. In the second example, there are multiple peaks. So in this case, like 2 is also a peak element because 2 is greater than this one also and it is greater than this one also. Then next 5. 5 is not a peak element. 6 is a peak element because 6 is greater than 5 and 6 is also greater than 4. So in this way we have multiple peaks and we can return the index to any of the peak elements. It doesn't matter which one we want to return. But the goal of this question is to find out the peak element. Means a simple search of a peak element and then return the index. That is all we have to do in this. So now let's try to understand what can be the approach for solving this using binary search. So in order to understand the approach, before we understand the approach for doing this, let's talk of the edge cases because there can be multiple peaks. So it is important to talk of the edge cases. So as we know, peak element is something which is greater than its neighbors. And the most favorable condition will be somewhere if the element is lying somewhere in the middle of the array. And we know that the element before that means the element on the left hand side or the element on the right hand side will be smaller than that, and hence that element can be a potential peak element. But when we talk of edge cases means what if this favorable scenario doesn't happen? What if the element is not exactly in the middle but rather the element is at the edge, at the either at the beginning of the array or it is at the end of the array? In those cases, how are we going to determine? So for that we will just write two simple cases that if the element means the first element, if this element is greater than the next element, then we can return 0, right? Because if this element is greater than the next element, obviously before 0 there is nothing else, it's a 0 based index. So then 0th index, the first element itself will be the peak element, so we'll return 0. This is one case. Or if the last element means ARR of length minus 1, if the last element is greater than the second last element, it's ARR of len minus 2, in that case we can return that index len minus 1. Why are we doing this? Again, the edge cases. If the first element itself becomes the element which is greater than the next element, there is no point in checking for the rest of the array, because we can return any of the peak elements, right? Whether it is at the beginning, in the middle, or at the end. So at the beginning only, if 0, the first element is greater than the next element, return that index 0, or at the end, means the element at the end of the array, the very last element, if that is greater than the element just before that, then that can be the peak element. So in that way we are saving us some time of not traversing the array, but rather returning the peak element right away. Why do we have the luxury of returning the peak element right away? Because we know this condition that it has to be strictly greater than the neighbors, and we can return any of the peaks. We have been told these two conditions. So that is why we are able to write these two edge cases at the beginning only. Another thing could be if there is only one element. So if there is only one element, obviously that element itself has to be the peak element. So that also we can just consider whether, if the length is equal to 1, you have to just return the first element itself. So these are the edge cases. Now let's talk about the actual problem that we have to solve. So this is a no-brainer. We have to use binary search. In case of binary search, some standard steps are there. We have this low pointer, we have this high pointer, which is low is the first element and high is the last element. And then we have a while loop, while low is less than equal to high and all of that. Now the actual logic is going to happen inside of this while condition, the checks, the conditions which you have to write, in which we have to determine the peak element. So now let's see how do we write those. So like we discussed, within this while loop we have to write the conditions. So what is the first condition? The most obvious condition, in which anyway we have to calculate the mid over here. So we will calculate the mid in the usual way, which is low plus high minus low by 2. Then we will check whether if this ARR of mid or whatever nums of mid, if this element ARR of mid, if this is greater than the element before that, that is mid minus 1 ARR of mid, and if ARR of mid is greater than ARR of mid plus 1. So this is the condition, the base condition that we were having. The element strictly greater than its neighbors. So it has to be greater than the element before that, that is on the left hand side, and the element on the right hand side. If these conditions are satisfied, we can simply return the index. What is the index? The mid itself. So we'll return mid. This is the first condition in which we are going to return the mid. The other condition will be if ARR of mid is lesser than the previous element, that is ARR of mid minus 1. So as in this case, 4 is the element, 4 is lesser than 6. So if at any given point in time the current element is lesser than the previous element, means the potential peak element has to be on the left side. So you have to go backwards. So in that case we have to decrement the high pointer. High should be equal to mid minus 1. So we should go leftwards in the search of the peak element. So this is the second condition. So now talking of the third scenario, what is in which if the ARR of mid is lesser than the next element, means the element on the right hand side, that is ARR of mid plus 1. So an example for this would be simple, like if we are at 1 and 1 is less than 3. So if that is the case, what we should do, we should increment the low pointer, we should go towards the right, because if this element is lesser than the next element, then this one has a more potential peak element, the ARR of mid plus 1. So you have to go rightwards in search of the peak element, hence we will increment the low pointer to be mid plus 1. So that's it. These are the three conditions, and at any given point in time when this condition, first condition, will be true, and then we are anyway going to return that index, which is going to be the index of that peak element. So with that, now let's see the code implementation for this. Now we're going to start with the code changes. So first of all, we'll have a variable to store the length of this array. Then we will write the edge cases like we discussed. So first of all, we have to check whether the size of this array is like if it contains only one element. So if n is equal to 1, in that case, we'll simply return 0. Then we will check whether the elements at the beginning, like we said, nums of 0 is the first element. If that is lesser than nums of 1, then we have to return 0, because we have to anyway return the index itself. And we can also put one more check over here, that the length of this, that is n, should be greater than equal to 2, because if there is only one element like we have over here, okay, we are anyway going to return 0. But for any other edge cases, if it is not equal to 1, if it is exactly equal to 2 or greater, is when we are going to run this check. Otherwise, if it is an empty array or something, then if this condition starts running for, in case of an empty array, then this 0 and 1 check will be invalid. So that is why we are explicitly specifying if the length is greater than equal to 2, only then do this check of nums of 0 and 1. And another condition which we have to also check is the last element. So nums of n minus 1, if that is greater than nums of n minus 2, then we will return n minus 1. So these are the three edge cases that we want to talk of, where the elements can lie at either of the extreme edges. Then we can begin the normal binary search. So where we'll define the low and the high pointers. First condition is if nums of mid is greater than nums of mid plus 1, and nums of mid is also greater than nums of mid minus 1. If this is true, we will return mid. We will check if nums of mid is lesser than nums of mid minus 1. So while we write this check, there is one thumb rule which we have to remember. Whenever in any binary search related question, we are trying to write the conditions relative to the mid pointer, like mid plus 1, mid minus 1, we have to think of the boundaries. So when I talk of boundaries, I mean when I'm talking of mid and mid minus 1. Okay, so let's say if the mid is the first element itself, somehow we reach to the first element. So mid minus 1 means will be out of bounds. So to avoid that kind of a condition, we have to make sure that this mid is not the first element. So it means it has to be greater than 0. We have to add this additional boundary check also. If it is greater than 0, only then it is a valid check to be done, like mid minus 1. So as we said, like if this condition is true, if the mid is less than mid minus 1, so we have to go towards the left side. So we have to decrement the high pointer, which will be equal to mid minus 1. Finally, we'll also write this check if nums of mid is lesser than nums of mid plus 1. So here also one boundary condition is like, let's say I'm at the last element and nums of mid, it's the last element itself. So mid plus 1 will again cause a out of bounds, because there is no mid, because there is no element next to the after the last element. So in that also we have to do this boundary check that mid is less than n minus 1, means it is not the last element. It can be the second last element and so on. So as we discussed, if this is the condition that is true, if mid is less than mid plus 1, then we have to increment the low pointer. Yeah, so that's all about all the three conditions that we have covered, and we are anyway supposed to return this mid. So with that, let's run this code. Missing return statement. Okay, so what we can do is we can just store this into some answer variable and can return the answer itself. Let me just run through the edge cases once. This is answer, and n equal to 1 return 0, and greater than equal to 2, 0 is 0. Oops, it's not greater than, it will be greater than, my bad. And if it is greater than this, then this. Okay, we'll run this. Looks like it's running into some kind of an infinite loop. That is why the time limit is exceeded. Okay, we'll run through this code once again. Low equal to 0, high equal to this. If low is less than equal to high, mid is calculated. The first condition, if this is true, answer is equal to mid. Okay, I think after we get this answer, we need not run this check anyway, so we can break. So let's try running this now. Yeah, so I think this break statement was missing. Because if you've already gotten the answer, there is no point in running through the loop again. So we can directly break out of the loop and return the answer. Okay, so yeah, that's all about this question. How to find the peak element in case of an array which contains multiple peaks using binary search. So hope you guys have enjoyed the session so far and have also developed a clear understanding of all the ins and outs of these questions, how to approach, how to solve, and everything. Do let us know in the comments below if you guys have any questions or doubts or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.